Have you ever just felt like you're searching for something? You know, a pattern, a meaning, some kind of connection in the world? Well, today, we're diving into one of the most fundamental drives there is, the hunt for meaning, that constant search for a signal in the noise.
You know exactly what I'm talking about, right? You're alone, it's quiet, except for the hum of a fan or the whir of the AC, and you could just swear you hear a faint voice, or maybe a distant radio playing. Don't worry, you're not going crazy. You're actually experiencing something deeply, deeply human.
There's a scientific name for this, of course. It's called auditory pareidolia. And what that really means is it's our brain's tendency to hear meaningful sounds, like speech or music, in just random fuzzy noise. Now, this isn't a hallucination. That happens in total silence. Think of this more like an illusion that needs a canvas of noise to paint on.
And here's the kicker. This isn't just some quirky glitch in our brains. This exact pattern-seeking instinct is the very same principle that kept our ancient ancestors alive. And now, it's the blueprint we're using to build the next generation of artificial intelligence. So, why? Why are our brains even wired this way to begin with? Well, to understand that, we've got to go way back in time. Back to a world where hearing a signal in the noise was literally a matter of life and death.
Evolutionary psychologists have a great name for it: the Hyperactive Agency Detection Device, or HADD for short. Basically, our brains are hardwired to make a simple, life-saving assumption. Any weird, unexplained sound is probably caused by an agent, something with a mind of its own. That rustle in the grass? It's not the wind, it's a predator. That snap in the dark? Not a twig, it's footsteps.
And here's the most important part. This tendency to see patterns everywhere isn't a flaw, it's a feature. And it's deliberately oversensitive. You can think of it like a smoke detector that's just a little too good at its job. Sure, it might go off when you burn your toast, but it will absolutely save you from a real fire. It's a system tuned by thousands of years of evolution for one thing and one thing only: survival. Now check this out, because this is where the evolutionary math gets really interesting. Look at the options. If there's a predator and you hear it, that's a hit. You survive. Great. If there's nothing there and you hear nothing, that's a correct rejection. No big deal. But just look at the errors. A miss, thinking a tiger is just the wind, means you're dead. A false alarm, thinking the wind is a tiger, well, that just costs you a little bit of energy. Evolution doesn't care if you get spooked 1,000 times by nothing. It just cares that you don't miss the real threat that one time. Auditory pareidolia is basically the ghost of all those life-saving false alarms.
So we've got this incredible ancient blueprint for finding meaning in total chaos. And what are we doing with it now? We're building that exact same instinct into our technology. We are literally teaching machines how to listen.
Let's start with a really simple but brilliant example. It's a project called Aural State. Okay, imagine trying to figure out if a computer server is healthy just by staring at endless lines of code. It's tough, right? Now, what if you could just hear it? That's the whole idea here. To turn abstract data, like CPU stress, into something you can understand instantly through sound. It's like a sonic debugger. And this just perfectly illustrates the parallel. Our brain takes random input, like a fan humming, and finds a signal, what sounds like a voice. This machine takes random input, like server data, and creates a signal, a meaningful sound, like a low drone that growls when the CPU is working too hard. In both cases, something is filtering noise to find real information.
Okay, so that's the simple version. But what happens when we really scale this idea up? We're now creating these incredibly sophisticated AI agents, like the ones in the LLM Vehicle project, designed to navigate super complex digital worlds. And these AIs don't just find one little signal. They can see their environment, they can remember what they've already done, and they can make new decisions based on that memory. They're actually developing a sense of time.
Now, the secret sauce here is something called a recursive feedback loop. In simple terms, it just means that the AI's memory of what it just did becomes a critical piece of information for deciding what to do next. It's really the difference between a simple reflex and real thinking. This loop creates this constant cycle of memory. First, the AI looks at its past actions and what's on the screen right now. Then it processes that history to figure out where the task is heading. Next, it outputs the most logical move. And here's the key. That new action and the new screen gets stored, becoming the immediate past for the next loop. It's just a constant cycle of observe, act, remember. Observe, act, remember. So this fundamental human drive, this need to find a coherent story in a stream of random information, it isn't just a survival trick or a programming puzzle.
It's actually the very essence of how we create and experience art.
Just listen to this incredible line from a review of Max Porter's novel Lanny. It says of the character, "I'm a million cameras, even when I'm sleeping." That just perfectly captures this idea of a character who is a constant, passive observer, just absorbing everything. See, in the book, Lanny becomes this living, breathing embodiment of pareidolia. He's described as a cohesion of all the voices and people he meets. He literally finds the signal in the noise of his village and makes it part of who he is. He's like a human soundboard. And our love of pattern seeking goes way beyond just the characters in a book. It's baked into the very structure of how we tell stories. We are just drawn to finding narratives hidden inside other narratives, kind of like those Russian nesting dolls, where each one reveals a new layer of meaning.
This literary trick is called a story within a story, or a nested narrative. And it's such a clever way to embed one plot inside another. It forces us, the audience, to become detectives, to actively search for the signal, the connection, that ties all the different layers together.
And you see it everywhere once you start looking. From Chaucer's pilgrims telling stories that define who they are, to the grandfather reading to his grandson in The Princess Bride. Or you can get really complex with the dream within a dream levels of Inception, or the crazy layers of manuscripts in House of Leaves. In every single case, we are drawn to the puzzle of it all, to finding the connection between the frame and the picture inside.
All right, let's bring all of this together. From the basic wiring of our brain to the code we write for our machines, and even the structure of our art, it's all the same search. This really is the fundamental drive. It's this one single unifying principle. The paranoid primate hiding in the grass, the smart AI navigating a program, the captivated reader lost in a book, they are all doing the exact same thing, filtering chaos to find a meaningful pattern.
In fact, you can see this filtering process at the absolute highest level. Our entire culture is basically a giant system designed to find signal in the noise. Think about literature. Thousands and thousands of poems get published every single year. How on earth do we decide which ones matter?
We use filters. This chart here shows how many poems appeared in the Best American Poetry Anthology, and you can see that out of literally thousands of literary journals, just a tiny handful consistently rise to the top. The New Yorker, Poem a Day, the Paris Review, they become the perceived signal. We collectively decide that these are the voices to listen for in the overwhelming noise of modern poetry. You could almost call it cultural pareidolia. Which of course brings us to a final, really crucial question. Our own pattern-seeking brain created gods and ghosts out of the rustling wind. And now, we are building machines with that exact same core directive: find the signal. So, as these AIs become more powerful, more autonomous, as they sift through ever larger oceans of noise, what signals will they find? What ghosts will they begin to see in the machine?